In this video, we will discuss basic concepts of simple interest and compound interest. We'll go over some of the formulas and what are the important things to remember when using the formulas. We'll also do problems 1 and 2 from the worksheet. When we put money in the bank, it grows no matter how small the percentage of growth is. It grows depending on the type of account that you put your money in. So let's look at the two types of interest, compound interest and simple interest, so simple interest and compound interest. Two different ways in which money grows, which means depending on the type of interest, the growth of money in your account is different. So just to clearly understand the difference between these two types of interest, let's take a simple example. So we deposit $1,000 in a bank at the beginning of the year. We consider two types of accounts. One is a 10% simple interest account, and the other is a 10% APR, which is annual percentage rate, which means that the interest is compounding annually. That is the second type of account. Now we'll see by doing some simple calculations how money grows in each type of account. So let's look at the simple interest account, which is account 1, at the end of the first year. So we're looking at the first row and we're looking at the second column. So we have $1,000 deposited in the account. How does money grow? According to the type of account, it is a 10% simple interest account. So what gets added on to the 1,000 that is deposited in the bank is 10% off the basic deposit, which is $1,000. So $1,000 is the basic amount plus 10% of 1,000 is 100. So 1,000 plus 100 is 1,100. That is the total amount of money in the bank at the end of the first year. So this is how the money grows in the first year. We start off with $1,000. We end up with $1,100 in the bank. Now suppose we look at the second type of account and how the exact same amount of money grows, but based on a 10% compound interest of $1,000, assuming that money is compounded yearly. So we start off with $1,000 just like before. What gets added on is 10% of what we have in the bank, which is $1,000. So 1,000 plus 10% of 1,000 is 100 is 1,100. So at this point, you're probably wondering what is the difference. You can see the difference only in the second step. So let's look at the second step, which is the amount of money in the two accounts at the end of the second year. So at the end of the first year, we have $1,100. What gets added on, and here we need to be careful about what gets added on, is 10% off $1,000. It is not a 10% of the existing amount in the bank, but it's 10% of what we started with in the bank. So that is an important thing that we need to notice. It's 10% of what we started off in the bank, not what we have in the bank at the end of the first year. So basically, the exact same amount, $100, gets added on to the existing amount, which is $1,100, which makes it $1,200. In contrast, let's look at what goes on with the compound interest account. So at the end of the first year, we have $1,100. So at the end of the second year, what gets added on is, and again, let's pay special attention to this, is 10% off not $1,000 but $1,100. That is the existing amount of money in the bank. Now, this is where it makes a difference. So I want you to notice the difference between these two. What gets added on here is 10% of $1,000, which is the amount of money we started with. What gets added on in the compound interest account is 10% off, not the 1,000, but the $1,100. So if every year we get interest on the existing amount, interest is calculated on the existing amount, then that is what is called compounding annually. In a simple interest account, we do not earn interest on interest. Now, similarly, year three, the same pattern continues. We have $1,200 in the bank, 10% of the first amount that we deposited is the exact same thing, which is $100 gets added on, which makes it $1,300. In year three, the compound interest account, we have $1,210 plus 10% of that amount, not of $1,000, if you see the difference here, gets added on. So we have a total of $1,331. So if you keep going down this list, you'll notice that every single time in a simple interest account, we are adding the fixed amount of $100, which is 10% off. So $100 is 10% off what we started with, the deposit that we made first. And that does not change. $100 is a fixed amount that keeps adding on. It's simple for that very reason, because you keep adding the same amount every single year. Now, in the compound interest case, what gets added on every year is 10% off the existing amount. So if you notice these numbers, the first year we add 100, the second year we add 110, the third year we add 121, the fourth year it's 133.1, the fifth year we add 146.41, the sixth year we add 161.05, and the seventh year we add 177.1561. So each time interest is calculated on the previous amount, which includes the interest earned over that period of time. So this is the big difference between simple interest and compound interest. So if you look at the end result, in the case of simple interest, at the end of 7 years, we have $1,700. In the case of compound interest, at the end of 7 years, we have $1,948.71. So money grows faster in a compound interest account, because we are earning interest not only on the first deposit that we make, but also on the interest that gets accrued over a period of time. Now, when we do calculations, you'll see in the next page that we do not have to go through all these steps. There are certain formulas that we can use. So in the previous slide, you've seen how money grows in a simple interest account versus a compound interest account. We went through the calculations from scratch. Obviously, if we had to do those sort of calculations for problems that we come across on a regular basis, it would just take forever. We need some formulas to help us out here. So here are some formulas that you're going to use to calculate interest and other things that we need in certain situations. So we have simple interest. Let's get used to some of these symbols that we use, some of the letters that we use. I stands for interest. Interest is the money that gets added on to the basic amount that we invest in the account. The basic amount that we put into the account is called the principal, P. It's also called the present value. So both start with the letter P. The present value. What is the value of the account now? In future, it's going to grow into a different amount because interest gets added on. So the future value or the amount, accumulated amount A, is principal, which is the first amount that we put in, or the present value, plus the interest. Now, rate is calculated as a percent. So if the rate is 10%, then that is equal to 0.01. I'm sorry, 0.10. Now, time, this is where we got to be careful, is always in years. And that's why in your textbook you'll see the time is denoted by Y. So it makes it very clear that it has to be in years. No matter which symbol we use for time, just make sure that if it is not in years, we need to convert it to years before we actually use the formula. So for example, suppose the time is given in months. Let's say the time is 4 months. So we cannot plug in 4 into the formula because that would mean that we are trying to figure out the interest or the principal or the accumulated amount for 4 years. So we need to convert the 4 months into years. So this is how we do it. 4 months times, and we use dimensional analysis, 12 months is equal to 1 year. So that is the equation we used to get the ratio. The months and the months get cancelled. 4 goes 3 times into 12. Years is the final unit left in the numerator. So what we have is 1 in the numerator and 3 in the denominator. So that makes it 1/3 of a year. So does it make sense to say that 4 months is 1/3 of a year? So in the formula, you are not going to plug in 4 months, but you're going to be plugging in the number 1/3 because that is in years. So that is the most important thing to consider. So let's go over the letters once again. I for interest, P for present value, the amount that you deposit into the account. It's also called the principal. R for interest rate, you could write it as a decimal. T for time that the money stays in the account, and that is always given in years. If it's in any other form, we need to remember to change it to years. So if you had to just figure out what the interest is, then that's the formula that gets you there. Interest is equal to the principal times the rate times the time. So this is a formula that helps us figure out interest alone, knowing principal, rate, and time. Now, what if we had to figure out the accumulated amount, the total amount of money that is in the account after T years? So that is given by the formula A equals P plus PRT. And using our knowledge of algebra, P can be factored out. So once we factor out P, we get P times 1 plus RT. So just remember that A is called the accumulated amount, which is principal plus interest. It is also called the future value of money because it's different from what we deposit, which is called the principal and also called the present value of money. Now, let's look at some formulas that we're going to use for compound interest. Now, if interest is compounded once a year, like the example that we saw on the first slide, at the end of every year, we calculated interest on the amount of money that was in the account the previous year. So then you would say n, the number of times it's compounded, is equal to 1. Now, sometimes compounding can happen more than once a year. A lot of times that can happen. So suppose I say uh, n is equal to 2. What does that mean? So instead of calculating the interest at the end of the first year, the end of the second year, the end of the third year, we'll be calculating interest every 6 months. So every 6 months, we figure out what the interest is in the amount that is in the bank up to that point, and then we add it on to the existing amount to find the accumulated amount. So n equals 2 would mean we are calculating interest every 6 months. Now, what if n is equal to 4? So that would mean that interest is calculated quarterly. What does it mean for interest to be calculated quarterly? It means that 3 times 4 equals 12, so 12 months. We divide it into 4 quarters of 3 months each. So every 3 months, interest is calculated. So that just means it's calculated 4 times in a year, and that would be n equals 4. We could go calculating it monthly. So if n equals 12, what that means is the number of times we are calculating interest, compounding interest, is 12 times a year. So we calculate interest at the end of every month, and that would be n equals 12. So that's what the letter n stands for. Now, if you noticed in the previous case of simple interest, if you look at the formulas, there is no letter n because the interest is always fixed. It doesn't depend on anything else other than the amount of money P deposited into the account. So if you see the letter n and the number of times it's compounded, then we are definitely talking about compound interest. Now, we have two formulas instead of going through all the calculations by scratch, which takes forever. So suppose an amount P is deposited into the account at the rate R, compounded n times a year. So the rate is R, number of times it's compounded is n. The accumulated amount A in T years is given by this formula. If we have to calculate P, the amount that we need to deposit in order to make a certain amount of money A at a certain rate when interest is compounded n times a year, then this is the formula that you will use. I just want you to notice that these two come from the same formula. Here the formula is solved for A, and if we solve for P instead of A, then we get this. So if you know one of these, then all you have to do is solve for the other in case that's what you need in a problem. Now, interest can be compounded once a year, twice a year, 3 times a year, 4 times a year. It can be compounded any number of times a year, including 365 times a year, which means it is compounded daily. So if it's compounded daily, then n is equal to 365. So you can keep compounding it more and more times, and money grows faster as you keep compounding it more and more. But there is a limit to it. You would think that if we are compounding it continuously, which means every second, every fraction of a second, every fraction of a fraction of a second, we would think that the money should grow infinitely, but that doesn't happen. If money is compounded, a certain amount of money is deposited into an account, and it's compounded at the rate of R continuously, which means infinitely many times. And it's really not a number, but just so you can imagine what continuously means. It's not once a year, it's not twice a year, It's not 365 times a year, which is daily compounding. It is continuously. It's infinitely many times a year. Then the formula is A equals P e to the RT. E is an irrational number. You can do the calculations using your calculator. Now, what does compounding in compound interest situation, what does n equals 1 mean? N is the number of times interest is compounded. So in this case, what it means is that interest is compounded annually, which means it is compounded once a year. So let's look at problem 1. It says find the simple interest on a $1,000 investment made for 3 years at a simple interest rate of 5%. The important thing is to note that it is a simple interest problem. So if it is a simple interest problem and we need to figure out interest, you can look at the formula that is given on the previous page, and we have I equals PRT. We know what the letter P stands for. It's the amount that's deposited into the account, and it's equal to $1,000. T is the time in years, so that would be 3 years. The rate is 5%, which is 0.05. The question says, what is the interest? So the formula that works best for us is I equals PRT. Important thing is to know this is the formula that corresponds to simple interest. We plug in all the numbers, we use the calculator, hit the enter button to get $150. If all we wanted to know was the interest amount, then that would be $150. What if we wanted to know the accumulated amount? So the accumulated amount would be equal to the principal plus the interest. So that is equal to P plus I, which is equal to 1,000 plus 150, which is $1,150. That is the accumulated amount. But what we needed was just the interest. So read the question carefully and figure out what you need to do in order to answer the question. The next question, the $60,000 is invested in an account with an annual percentage rate of 5.5% compounding daily. Remember, we talked about this. Daily compounding would mean compounding 365 days in a year. The amount that you invest into the account is 60,000. R is the rate. Rate can be written as a decimal, 0.055. That's the number you would plug into the formula. We need to figure out what happens to this amount, or what happens to the principal at the end of 25 years. So that would be, what is the accumulated amount at the end of 25 years? A equals P times 1 plus R over N whole to the NT. So plugging in all the numbers, hit the enter button on your calculator and you get this answer. There's just one thing. I would suggest you enter all the numbers at one time. Do not round in any of the numbers in the middle, because your answer will be off by a certain amount if you're doing the rounding in between. So I would suggest entering 60,000 times in your calculator, open parentheses, 1 plus 0.055 over 365 without any parentheses. You don't need those. And depending on what calculator you have, you may or may not need parentheses here. Make sure that these two sit in the numerator, 365 times 25. Make sure they're sitting in the exponent's place. So if your calculator sometimes might need parentheses, and sometimes the tab goes to the exponent's place, so you don't really need parentheses. Hit the enter button. No matter what you get, you can round it to the second decimal place if it is money.